Welcome back. This is an Aleks training video on writing an acid dissociation constant expression. So dissociation is when you put something in water and it breaks apart into ions. And acids do that, even acids that are not ionic. So if you were to say like HCl, which is H is a nonmetal and chlorine is a nonmetal, they are bonded covalently. So they're not ions, but when you put a strong acid in water, it completely dissociates. It breaks apart into positive and negative ions. So when you have a dissociation constant, what that's doing is showing that you have an acid, you're putting it in water, and then the hydrogen or the cation or the proton is breaking off, and it's leaving the conjugate base in the water. Okay, so first of all, let's go ahead and write the formula of what's actually going on. So you know that an acid breaks apart, so this is aqueous. Okay, so I'm going to have HCH3CO2. There's your acid. It's aqueous. And it says with water, so H2O, and that's a liquid. Okay, now remember that liquids and solids, when you do the expression, when you do the equilibrium constant expression, you're going to ignore it. The water goes away. You're just going to ignore the water. Okay, so when it happens is that it breaks apart and joins up with water. So let me put something over here to kind of help you. Water will attract a proton. So when you pull off a proton, water can accept it. Water can act like a base. And when that happens, that's called a hydronium, which is H3O plus, and that's called a hydronium. And when you say pH, when pH of something, and you're testing the acid, the H in pH is not hydrogen, the H in pH is the hydronium ion. So how many hydronium ions do you have in the water? That tells you how much acid's in the water, because as soon as a proton comes off in the water, it will join to a water molecule and make a hydronium. So it's essentially an acid. It looks like an acid itself. All right, so I've got water is going to catch that acid. Okay, so this guy is going to be pulled off and joined to the water. Okay, so this is what you're going to get. You're going to get a hydronium ion as a result. So this is H3O plus, okay, and H3O plus is aqueous. Only the water is liquid. And then you're going to have whatever's left over, the conjugate base of this acid. Okay, so we did this before. So the H comes off, takes a positive with it, makes this whole thing become negative, and then this is the leftover. Whatever's on this side is left over. Okay, so this is going to be CH3CO2, all of that's minus, and that's aqueous. All right, now the expression, or the constant expression, okay, is going to be, now this is an acid, so we're going to call it K sub A this time. We've had K sub C for concentration. We've had K sub P for pressure. All of these are constants, K for constant, and so it's K sub A for acid dissociation. And remember, to make it, you're using concentrations of whatever you see here raised to the power. Okay, I guess I should check first to see if it's balanced. I've got 4 H's, 6 H's, 6 H's, 2 carbons, 2 carbons, 3 oxygens. Okay, it is balanced. So balancing would help. You have to balance it, because remember, you're taking the concentration to the power of the coefficient. So if there's a 2 or a 3 or whatever, that becomes a power. So you have to balance the equation. That's the next step. All right, so now we can take everything in order. We're going to do everything in the products first. So we have H3O plus raised to the first power, CH3CO2, that's minus, raised to the first power. And now go back and do the reactants. HCH3CO2 raised to the first power, and you're going to not consider the water because the water is a liquid. Okay, and that's it. That's how you do it. So this is K sub A equals the concentration of hydronium, the concentration of all of the products over all of the reactants. Okay, need practice doing this, I think, but we'll do it in class together.